Well, good morning, everyone. Thanks for joining us today. My name is Nick Bryant with Long Building Technologies. I'm in our Fort Collins office, and along with Richard, I'll be presenting on the Valent rooftop unit. A little bit different than weeks past is that we're doing a giveaway for watching our presentation, so make sure you stick around until the end to see what you won. And with that, I'll hand it over to Richard.
Thank you. So I'll kick this off with just a real brief overview of who Valent is and what we build. So we're a manufacturer of packaged rooftop units for high outdoor air products. So the majority of what we do is high outside air, but we can also just do a premium lower outside air rooftop unit as well. We came into the market back in 2007, so we've been building DOAS products for a very long time, and that's really our sole focus. We started with this type of product, and this is still what we 100% focus on today. So we feel we do it very well. One of our hitches we have on the market is we provide a very high quality product, and I'm sure you guys are used to people saying that. You probably don't hear many say they provide a crappy product, but my intent here in this 15 minutes is to kind of show you the proof points of what we do to provide that high quality product. So before I get into that, some of you may or may not be familiar with Valent. Those of you who are, one of the new things we've been doing over the last several years is we've really been adding manufacturing footprint to keep our lead times low. So the two red stars is Tulsa, Oklahoma and North Carolina. That's our two newest factories. We added those a couple of years ago. And since then, we've really been driving our lead times down to what we feel is a very good aggressive point in the market. Our goal is to stay at around 5 to 6 weeks as standard. And right now we're currently at 4-week lead times.
5 to 6 weeks, pretty quick as it is. Do you guys have any quick ship options in sort of an emergency situation?
Yep, so we're working on that right now, and in December we will be launching a 3-week quick build option as well for the product. So as far as capacity, range, and capabilities of the product, we can go from 500 to 18,000 CFM and 4 to 70 tons. And we do that by spanning it across multiple box sizes like you see here on the right of the screen. So we are a configurable manufacturer, which means we give you just lots of different options to pick and choose from to give you this equipment range. As far as cooling capabilities, Package DX is the majority of what we do. We can also do a split system, an indoor unit with a paired up their remote condenser, keep the compressors inside. We can do a water source heat pump or an air source heat pump and chilled water cooling. And then on the heating side, gas heating is our most typical option, and we can go up to 1200 MVH on that, but we can also do electric or hot water. And then we can incorporate energy recovery into the products, and we have the most energy recovery options available of anyone in this market. So we do energy wheels as kind of the standard, more typical offering, but we can also do enthalpic cores or plate heat exchangers as well. So here I'm just going to talk through some of the, the proof points of how we build a quality casing and a quality product. And, it really starts with the outside air intake. You can put any damper in. We could pick the cheapest damper possible. We don't. We can pick a class 1A low leak damper, and that's where we start bringing air in through the units. Our exhaust fans and supply fans are always direct drive. You may take that for granted. I think that's pretty typical. It is for a lot of manufacturers. There's still quite a few that on the exhaust fan are using belt-driven technology, and we know direct drive is better for maintenance, better for efficiency, and that's what we always put in all of the fans in our product. You can also handle higher statics. We always use a full-size energy wheel. And again, this is probably something you take for granted, but not all manufacturers do. So if you specify 5,000 CFM of outdoor air, you probably assume 5,000 CFM is going through the wheel. When you're using a Valent product, that's always true. Some of our competitors, that's not the case. Sometimes they bypass air on the wheel to avoid going up to a larger cabinet. So if you ask for 5,000, they may only put 4,000 through the wheel, bypass 1,000 around it, and mix so that they don't have to go up to the next cabinet size to fit the right sized wheel. So something to keep an eye out for. That's not something we do. We always put the full ventilation air through the wheel. We have advanced filtration options. So, the standard is 2-inch MERV 8, but we can do MERV 13 or 14 filters as well. We separate the DX and reheat coil. A couple of reasons. One is to get a good accurate temperature measurements for dehumidification mode. And 2 is to avoid re-evaporating condensate that may be forming on the DX coil. I know in you guys' territory that's not as big of a problem as it is in some areas across the US. And then we use all high turn down components, right? Including the furnace, fans, compressors, everything. So when we're doing a lot of ventilation air, we get pretty big temperature fluctuations. And at our peak loads, that's not really a problem. Let's say with like a standard 3-to-1 gas furnace. But if you were on a part load day and you only needed a little bit of heat, and let's say you had a demand control ventilation or a VAV unit, a 3-to-1 furnace might give you a 40-50 degrees of rise, which would be way too much. So that 16-to-1 can really come in handy when you're talking about ventilation air and turn down on the fans.
By having that high turn down, our climate really seems to make a lot of sense. One thing that I noticed is our compressors are up off the ground and in their own cabinet. Is there a reason that we do that?
Yeah, absolutely. So it's noise, right? So the compressor is one of your biggest noise sources in the unit for transmitting noise down into the building through the roof or just radiating noise into the ambient surroundings. And so putting that compressor on an insulated shelf and behind an insulated door really minimizes any noise that's coming off from that compressor.
That makes a lot of sense. And it seems like often with high outside air applications, what's driving that is high occupancy, like a school, where sound can be critical. Is there anything else that we do with our unit?
Yep. So our condenser fan, right? That's another source of ambient noise. And we use all low sound condenser fans. And I'll dig into those a little bit more detail in the next slide here. So how do we produce a low sound condenser fan? Well, we use this blade you see here on the right. It's a serrated blade. It looks like an owl's wing. This is made by Zielobig is the manufacturer. It's called the Owlet fan. And that particular blade profile does a really good job at reducing the noise from the condenser fan. And in our lab testing that we've done, it's about 8 to 12 dB quieter than a traditional just paddle blade condenser fan you may see with other manufacturers. And to put that in perspective, what does 8 to 12 dB mean for our ears? This chart down here on the right, you can see, standard fan operates somewhere in between kind of a vacuum cleaner and a lawnmower. It can be pretty noisy when it's running at full speed and you're standing right next to it. In comparison, the fans we use run just a little bit louder than a normal conversation. So it's a pretty significant noise difference with these fans. For head pressure control options, we can do 2 different things. One is we just modulate one of the fans up and down, and we would use an EC motor at that point. And the second option is we would modulate all of the fans together. And so I'll go into a little more detail about what are some of the advantages of doing it with all of the fans. So if you think of a 4-fan example where we have 1 horsepower in each fan, right? At full load, we're running 4 horsepower, whether we stage the fans, whether we have lead EC fans or all EC. Sounds the same, right? So when all fans are running, doesn't matter what head pressure control strategy we got the same scenario. But now let's say we have half the required load, right? So if I'm just saying I just have 1 fan that modulates up and down, well, it's half the load. 2 of the fans are just going to be off. 2 of the fans are going to be on. So you've cut your horsepower in half, and your sounds come down a little bit because you got 2 fans that aren't running anymore. With an all EC motor offering, we would modulate all of those fans down, right, to the 50% speed. As a result, because of the cubed fan law, we'd be running at 1/8 of a horsepower. So we actually total power, we're now running at 1/2 horsepower. So pretty significant savings compared to just a standard 1 modulating fan head pressure control option. And then you can see the sound greatly reduces as well. So not only we're using low sound fans, but if you modulate all of them down together, you're dropping it even lower. So it really produces a quiet operating unit. So then let's get into what else makes noise in the unit. We touched on putting the compressors behind a wall to help with this, but there's other things you can do too. So our 2 main compressors we use is a digital and an inverter. Both of these do a great job at capacity control, right? They both modulate to meet the temperature set point. They're both really good compressors when it comes to that. The advantages you get from the inverter scroll is really on the efficiency side and on the sound side, right? So it's not that the digital is a bad compressor. It's not. We've used it a long time. Still a very good compressor, very reliable, gives you great temperature control. But when it comes to sound and energy, the inverter definitely wins out. And so this first chart here shows you efficiency of the compressor as the compressor turns down to meet temperature set point. So if you go to the right side of the chart, that's both compressors running at full speed. They're about the same efficiency. But then if you move down the left side, as the cooling capacity drops and the compressors unload, the digital's the orange one, it gets less efficient over time. as it's turning down, the inverter compressor gets more efficient. So that's how we get that nearly 20% unit IEER savings from using an inverter versus a digital.
So with the inverter compressor, obviously there's huge efficiency savings. And again, how does that impact sound?
Yeah, so same thing on the sound side. So this next chart here, if you start on the right side, that's 6,000 RPM. That's the full load speed of the compressor. And so that would say, let's 100% capacity. That's what the compressor is running at. As the compressor unloads and it starts turning down, you can see on the left side, it goes up from nearly 90 dB at peak speed down to 65 at its lowest. So tremendous sound savings as the compressor turns down. And conversely, one of the biggest knocks on a digital compressor is it uses an unloader valve to do its modulating. And that valve can get very noisy. So actually, as it's unloading, it's a pulsing noise. It gets louder and then quieter, louder and quieter. And frankly, we'd rather have just a gentle standard hum than a pulsating changing noise. So it can be a real irritation on the digital scroll. The VFD does a great job at being nice and quiet. And when you combine that with those low sound condenser fans and the compressors in an insulated cabinet, we provide the quietest unit available on the market. And we also have factory sound lab tested sound results in our submittal, so you can actually see how quiet does it get, not just take our word for it. Last thing I'm going to touch on is just controls. So we do something unique here. We provide what we call the WebUI. So you can log into our controller and see like a traditional BMS screen like you see on the right here. And so this can really be used for two things. One, you can use it as a little, when I say BMS, way to control our units. It's not going to control the rest of the things in the building, but you can plug in an Ethernet cable and you can log in an IP address and use it for that functionality. It also is a really nice service troubleshooting and startup tool. So you don't have to have it plugged in. You can walk up to the unit and plug it into your computer just through the jack and plug it into the controller, and you get the same screen you see on the right, which if you've ever used the typical user terminals that come on control boards, they work, but once you have to go past a screen or two, it can get really clunky and irritating. So most of us would rather see a screen like this, where we can go in and say, what is the unit doing? What are our current set points? What am I currently operating at? And make adjustments. And that's what we provide in here. And then you can see all the different conditions that are going on in the unit. This schematic you see here changes based on your configuration of the unit. So if you had an energy wheel, you would see an energy wheel in here. It's not just a kind of dummy schematic. And then you can also use it for alarms, trending, and service. So one of the biggest challenges if you do have an issue with a unit is it turns off. It fires off an alarm. Someone has to go up there and maybe reset it. Maybe it self restarts. But the curiosity is what happened, right? So with the WebUI, you can log in and see any alarms that have happened over the last 2 weeks. And you can see a trend of what happened up to that alarm. So this can be invaluable for troubleshooting when you have situations come up. So you don't just restart the unit and run into the exact same issue. You can jump in and actually solve the problem. And then lastly, we have some service troubleshooting tools in here as well, where you can dig into digital inputs, digital outputs. You can do manual overrides, turn things on and off and see how they react. So a really useful tool. So we love to always do all controls. And like I said, we've been building these products for 15 years, and we bring over 30 years of experience from our partner Innovent. And so we like to do full controls. That being said, we understand sometimes you have your own building system. You want to have the same controllers across all the units. You got a campus control system. So in those scenarios, we do have a controls by others option. For that, we still do the safety controls. So we'll have a controller in there to stage our compressors and stage actually the furnace valves. And then you can send us through a terminal strip, just 0 to 10 signals, start-stop signals for the fans, everything else. So still use the main building controls you would like, but we maintain the safety controls of the refrigeration system and heating to make sure that they are operating efficiently and as safely as possible. So that's a quick overview, but that's kind of Valent in a nutshell. And would love it if you guys, use the product. If you have any questions, obviously reach out to your contacts at Long here.
Thanks, Richard. And for next week, Jason Long will be talking about the Munter SiteCool system, which is a great fit for data center applications, especially in our market. That has a first stage circular heat pipe, essentially where you have no mechanical cooling or free cooling, and then a second stage active TX compressor.